Hello class, what's up, is Raj here. So today we are discussing about the class 9 science chapter 4 is structure of atom. So in this chapter we are discussing about the simple structure and easy to revise and copy friendly for the examination. So first topic is class atomic theory. The atomic theory is given by the Dalton. So atomic theory given by the Dalton and Dalton in 1803. Okay, the timing is 1803. What is the postulates of John Dalton? So first of all, matter is made up of tiny particles called atoms. So all the matters, if you're thinking about, for example, this is also an atom. So how these are made up of? This is made up of the teeny particles, the small molecules, including other atoms. Sorry, molecules, not atoms. So atoms of same element, okay, the same property including are there first of all, and the atom combine in a fixed ratio. There is a fixed definite ratio to combine with each other. So these are come under in the atomic theory. So next, what is the limitations? So atom is divisible. Okay, what is the type of divisibility? Electron, proton, neutron. That the thrice are exist first of all, and the isotopes have a different masses. If you're talking about the isotope, that's a different mass including out there. So these all are come under the limitations of the Dalton's atomic theory. Next we talking about the J. Thomson model, that is also known as class plum pudding model. Okay, if you take the example of the watermelon, then there's a small black seeds. So the small black seed that come under in the watermelon, that is also the plum pudding model. So first of all, discovery of electron. How the discovery of electron? Sorry, when the discovery of electron happened in 1897. Okay, atom equals to positive sphere first of all, and the electrons embedded like a seed. Okay, just I'm telling you, just give example of the watermelon, just like that. So atom is a neutral. First of all, atom behave like a neutron. So what is the limitations? Could not explain the arrangement of the particles. This telling about the particles but could not explain the arrangement of the particles. This is the major drawbacks of this model. Next class, Goldstein experiment. If you're talking about the Goldstein experiment, how does this happen? So the canal rays, that is denoted by the positive rays, discovery the protons, that is denoted by the plus, and opposite to the electrons, these are the opposite to the electron. So these all are come under in the Goldstein experiment. Next class, Rutherford model. If you're talking about the Rutherford model, how this happened, the what is the model of it? So the gold foil experiment including are there. First of all, observations. So observation is it, that is the interference. First of all, the interference including are there. Most particle passed. First of all, the atom mostly empty at that particular time are there. After that, few are deflected. Okay, few deflected because of the positive charge exist in it. Okay, and second, few bounce back, the nucleus present in it. So these all are come under in the gold foil experiment. Next, what is the conclusion of this? So first of all, nucleus equal to small and positively charged. First of all, just 1 second. So nucleus equals to small and positively charged, and electron revolve around the nucleus. Okay. Next, limitations could not explain the stability of atom. It could not explain the stability of atom. First of all, okay. Chadwick discovery. If you're talking about the Chadwick discovery, if you're talking about the Chadwick discovery, that is denoted by the neutron in 1932. First of all, and the neutral particles including are there, and there is a no charge and present in the nucleus. So these all are come under in the Chadwick discovery. Next, subatomic particles. If you're talking about the subatomic particles, how these things will happen, the location and the electrons, protons, neutrons. So that is denoted by the E naught, you know, that P plus N naught, -1 +1 0 charge, and the positions, that is the outside nucleus, nucleus. Okay. Next, nucleons. What about the nucleons? If you're talking about the nucleons is the combination of the protons and neutrons. The both are made up of the both are mating the nucleons. So nucleons equals to proton and neutron. Remember it. So atomic number and the mass number. Atomic number is always denoted by the jet. So the number of proton equals to Z is equal to P equals to E. GP, the mnemonics of that particular thing as is GPE. Okay, ZPE. So in this, we are knowing that class, the atomic number that is denoted by the Z and the number of proton Z equals to P is equal to E. So first of all, if you're talking about this, the mass number that is denoted by the capital A equals to proton and neutron, both are combining to each other. So the formula of neutron equals to A minus Z, including in this formula. So next class, Bohr's model. So what do you mean the Bohr's model and what is the postulate of it? Is the postulate we are talking about, the electron revolve in a fixed shell K, L, M, N. There is a 4 shell are including on there. First of all, K, L, M, N. So energy levels are fixed. First of all, the energy levels are fixed in it, and no energy loss in orbit. There is a no energy loss in orbit. So there is a jump. Energy observes or emitted. So both are in this. Okay. Next, if you're talking about the electronic configuration, the formula equals to 2n square. Okay, the cell K, L, M, N. The 4 things are including in this, and the max electron 2, 8, 18, 32. That are electronic configuration including are there. So there is an important rule that is also known as class octet rule. Very important rule. There is the outer shell max is equal to 8 electrons are there, and the stable atom is equals to 8 electrons in this. So after that we are knowing that class, the valency including are there. So valency equals to combining capacity, first of all, depends on outermost electrons. If you're talking about the dependability, so the dependability on the outermost electron according to the valency are there. For example, sodium, if you're talking about the sodium, that is 1 loses 1 electron in it, and the chlorine, that is 1 gain 1 electron in it. So this come under in the valency. Next class, isotopes versus isobar. So these are our last topic are there. After that, let's see. So isotopes, same Z, different A. That is the isotopes. Okay. Example C12, C13, C14. Isobars, same A, different Z. So example are AR40, CA40. Okay. Quick revision. Here at a format, what you say. Okay. Atom, smallest unit. Electron, negative. Proton, positive. Neutron, neutral. Z equals to protons, A is equal to P plus N, 2n square rule, octet equals to 8 electrons, Rutherford nucleus, Bohr cells. So these are the quick revision for you that I'm making for you, sorry. So thank you so much. Please like, subscribe, share my channel how much you can. Jai Hind, Jai Bharat.